Hi, welcome to Kapati Math Classes. This is your Murali Krishna. This is the 70th video on single variable calculus. We are discussing about examine a function or investigation of a function. Under this, we are discussing about different tools which we used to examine or to investigate a function. In 15th and 16th videos, we demonstrated about monoids only of a function and we did some numerical questions also. In this video, we are going to analyze or examine a function using the tool periodicity of a function. Periodicity. Periodicity of a function or periodic functions. Now what is this? Let's say for example I have let y is equal to f of x is any function and this x belongs to domain of f. What this function will do? For different inputs, it gives outputs. Say for example, for x1, say x1, x2, x3 and so on, xn are the inputs. And the outputs are we got outputs are f of x1, f of x2, f of x3 and so on, f of xn. Now, after finding these n values, I want to put xn plus 1. Okay, for xn plus 1, amazingly, I got my f of xn plus 1 and f of x1 are same. And if I try to give next one f of xn plus 2, I got f of x2. That means the function is going back to its original position. So this type of experience, this type of repetition in working rule of a function is called periodicity. So in periodicity what happened, after giving n inputs, if I try to give next input, it goes to the original position. So this type of phenomena, this type of experience is called periodicity of a function. Now let us discuss thoroughly about what is meant by periodicity of a function. The basic definition of periodicity of a function. Let y is equal to f of x is any function where x belongs to domain of the function. If there exists at least positive real number, say t, such that f of x plus t is equal to f of x for all x belongs to domain of f, then f of x is called periodic function. And this t is called period of the function. And t is called period of the function. Okay, now I will explain you about this least positive real number by taking an example. Why? Of course, positive real number t is okay. That means after the length of the t, the function is going back to its original position. But why this word least positive real number? I'll take an example. For example, we have, let's say, example, f of x is equal to sin x, and x belongs to real number set. Let us observe the graph of the sine function. Observe the graph of sine function. This is 0, this is pi, 2 pi. Now I draw the graph of the sine function between 0 to pi. So between 0 to pi, it goes like this. At 0, 0, at pi is also the graph. 0 to 2 pi. Between 2 pi to 4 pi, this is 3 pi, this is 4 pi. If you observe carefully, between 2 pi to 3 pi, again it goes like this and coming down. So here the shape of the graph between 0 to 2 pi is same as the shape of the graph between 2 pi to 4 pi. And if you go for 4 pi to 6 pi, 4 pi to 6 pi, the graph will be like this. 6 pi to 8 pi, the graph is like this. It goes on continuously. So here the shape of the graph between 0 to 2 pi is repeating the same in the 2 pi to 4 pi also. Same thing you can see between 4 pi to 6 pi. You can experience same thing between 6 pi to 8 pi also. So easily we can say the period of the sine function is 2 pi. Again repeat, the period of a sine function is 2 pi. Okay, that's first point, one, period is 2. But if you observe carefully, why don't we say this function period is 4 pi? Why? Because the shape of the graph between 0 to 4 pi and between 4 pi to 8 pi, the both are same. The shape of graph between 0 to 4 pi and 4 pi to 8 pi is also same. So we can take the period of the sine function as 4 pi also. Not only that, I can take the period of function 8 pi also. So here 2 pi is a period, 4 pi is also period, 8 pi is also period, and so on. Among all these, 2 pi is the least one. So we consider only the least positive real number to count period of the function. To count a period of the function 2 pi, 4 pi, 8 pi, and this 2 pi is called fundamental period. That means for any function, let's say for example t1 is greater than t. T1 also can be period, but t is a fundamental period. T2 is more than t1. T3, sorry, okay. T3 is more than T2 and so on. So I can take T1, T2, T3 also periods. But among them, T is the least one. So T is called fundamental period. We consider only the least positive real number as a period of the function. And let us discuss about some examples. To find period of a function. Number one, first point is, let y is equal to f of x is any function is any function with period. As usual, I'll take t. Then the period of say a times f of ax plus b is t by mod a. It's very simple process. F of x period is 2 t. Now a times f of a x plus t by a plus b is equal to a times f of ax plus t plus b is equal to a times f of ax plus b plus t. So I can take a times f of ax plus b, so which is original one. Therefore the period of a times of f of ax plus b is t by mod a. Why have taken mod a? Sometimes a can be negative. Now here, very important thing here, in a times f of ax plus b, what do you call this a? The a is called amplitude, harmonic amplitude. A is called amplitude. Of course, we take mod. I will explain you by taking one example. And what is this a is called? What is this a is called? And this b is called phase. Now I will explain you all these by taking one example. Let f1x and f2x are two functions with the periods t1 and t2. Then the period of f1x plus or minus f2x, or f1x times of f2x, f1x divided by f2 of x. In all these cases, you take LCM. You know what is LCM? Least common multiple of t1 and t2. Of course, t1 and t2 are rational numbers. Okay. Now, this is the second property. Now, these are only the two rules we use to find period of a function. Okay. Now, first, the period of f of x is equal to sin x is 2 pi. Here frequency is 1. And second one, the period of f of x is equal to cos x. is also 2 pi. And finally, the period of f of x is equal to tan x is pi, 2 pi radians, 2 pi radians, pi radians. Now using these basic properties, we can find the period of any trigonometric function.